Greetings everyone, I am Kim Manesca, together with Jasmine Carreon. We are going to explain the algorithm we made for the topic assigned to us, which is bisection method. But let us define first this topic. Among all the numerical methods, the bisection method is the simplest one to solve the transcendental equation. The bisection method is used to find the roots of a polynomial equation. It works by narrowing the gap between the positive and negative intervals until it closes on the correct answer. It is a simple method and it is relatively slow. The bisection method could be called as binary chopping, interval halving, or Berzano's method. This method is an approximation method to find the roots of the given equation by repeatedly dividing the interval. It is one type of incremental search method in which the interval is always divided in half. Now, going to the codes. But disclaimer, we are not professional nor skilled programmers, but we tried our best to do and work on the codes to come up with this project. The first thing that you will see in the program is the header file. And then, we declare the variables needed. We managed to work on the equations. We work on this so that not just only one degree could be used by the user of this code. We came up to the idea of asking first the degree of the function, which is from third degree up to 10th degree only. So if you put an equation whose degree is 2, it would automatically show error since the scope will start only in third degree. After asking the degree of the function, the next thing to do is to input the coefficient per degree. Then, the number of decimal points to be appeared in the table will also be asked to the user of this program. Once the equation is already settled, this is where the initial guesses will be asked to enter. Since in the bisection method, there are two initial guesses, there are two values to be asked in the program. This corresponds to the x sub n and x sub p values. As we taught to us, there are 6 columns in doing the bisection method table. In this program, you will see 6 columns as well. In doing the table to be appeared in this program, we work on the formulas and functions per column of the table. After setting up the formulas, we put some conditions. It is necessary thing to do to have an accurate computation using bisection method. Once the value of a given midpoint becomes 0, the iteration will automatically stop, so the root of the equation will be the last value of the midpoint or x sub nw. But if the value of f, x, and w is positive, the value of x sub n will remain unchanged, while the value of x sub p will be changed into the previous value of the midpoint. On the other hand, if the value of f, x, and w becomes negative, the value of x sub n will change into the previous value of the midpoint, while the value of x sub p will remain unchanged. Let's try to compile the codes. As you can see, there is no error in the codes, so we can run the program now. To test the program, let's do some examples. For the first example, let's try to solve for the root of this equation. This equation was solved manually before. Let's see if we will arrive at the same answer. The degree of the function is 4. Then enter the coefficient 1, 3, -5, -7, and -10. For the number of decimal places, 5. And for the first guess, x sub n equals 2, x sub p will become 3. And for the degree of accuracy, 0.001. And the root of the equation is 2.09082. Now, to compare it, let's use the Desmos in finding the root of an equation. In the Desmos, the root showed 2.09. But this is just one root only of the equation. Let's try to solve for another example. For the second example, let's try to find the root of this equation. The degree of the function is 5. and then enter the coefficient 1, -3, 3, 6, -12, and -4. For the number of decimal places, 5. For the first guess, x sub n will become -1 and x sub p is -2. And for the degree of accuracy, 0.0001. The root of the equation is -1.38556. Let's compare it using the Desmos. In Desmos, the root is -1.386, which is also the same with the program. But again, this is just only one root of the equation. Program created is limited to polynomial equations whose from third degree to 10th degree only. It has no approximate true error computation. And the encoder can customize the specific number of iteration he or she wants to appear on his table. But again, we tried our best to do this project. Thank you for watching!